Welcome everyone. You're in the right place to see our iLogic presentation with Carl Smith and Tim Strandberg. Gentlemen, the floor is yours.
All right. Good afternoon. Good morning, everybody, wherever you are. I want to welcome everybody, as Janice said, to our webcast this morning. It's myself, Carl Smith. I am with the Manufacturing Services Division of Imagineit, running around all over North America, helping you guys with various manufacturing-related consulting engagement. Tim Strandberg is also part of our team. He is also quite busy, running around doing consulting. Tim is a specialist with our automation and development type things, so he gets to delve around in a lot of code and code work and scripting and C+ and C# and see what I mean. It's all over the place. So Tim, we're privileged to have Tim show us a few fancy things with iLogic today. So we'll go ahead and get started with our usual intro slides. Again, who we are. I'm part of the Imagineit team. We're part of the RAND Worldwide umbrella. Our sister companies being RAND 3D and Ascent. So our part of the pie here and what we do all over the place is specialized as Autodesk integrators and consultants, as well as ArcBucks and Pixel 4D and Leica scanning systems, all kinds of things. My division is, of course, the professional services and training. The relationship that we have, part of the who we are, the relationship we have with Autodesk is, as their leading provider for their software, they're also our largest customer. We do a lot of services work for Autodesk as well. Our specialty for our services include our Take Aim program, our Productivity Now support programs, and one of the things we're very, very proud of is our award-winning, top-rated customer satisfaction. Our Autodesk is really picky about how we take care of folks. After all, our customers are their customers, so we're constantly graded and tested and graded and tested, and we're very, very pleased to be a top vote getter or top award winner for our customer satisfaction. So we're quite happy with that aspect of it. Now our slide here just simply shows you where we are throughout the country. There's all kinds of offices everywhere. I guess this is just an indicator that we're not a one-stop shop where we have we're just as wide as we are deep with our experience, and no matter what you're trying to accomplish and where you're, if you're in the shipyards or transportation of some sort or another, or in manufacturing world of machine design or consumer products or any of that kind of stuff, somewhere one of our engineers and consultants in one of these offices has some experience dealing with customers from that aspect. And I get to see dozens and dozens of you guys all the time, all over every quarter, every year. But if I get stumped and I haven't seen a particular instance or a particular situation and I'm looking for best practices and workflows, this just kind of illustrates that I've got lots of resources that I can talk to about such things. Same with Tim. Now, before we get started and actually I turn it over to Tim, I did want to just kind of, again, just an overview for those that are new on the presentation about what iLogic is. It basically extends Inventor, right? Without reading this whole slide deck, it allows you to build rules. The rules just indicate well, if this happens, then that happens, or else this will happen. Those types of things. It's basically the rules that are behind and that can be built behind Inventor to add logic to a model. Okay. Now, traditionally, when you use parametric modeling, like Inventor started out, like so many CAD systems are nowadays, it's dimensional parameters and it's equations, right? The A plus B equals C. So we're going to take C and make this particular parameter is equal to C plus 3, and this is equal to C minus 4, and all that kind of stuff. So there's lots of ways to do mathematical calculations to help you build a parametric model. You can even link it to a spreadsheet and let the spreadsheet do some math for you. But these rules behind iLogic allow you to define a model conditionally. Conditions can be both equations and parameters like we're used to, but they can also be defined as a combination of parameters and properties and attributes, so it can evaluate all of those things before it makes a decision and returns a result. So it also lets you define a relationship between every object in the design. So you can evaluate the entire assembly before making a decision, before the system can make a decision on what the next step will be, or what the next phase of the design is going to be, or what kind of concept you're going to be able to develop from there. So that's what they mean by conditional definitions. So here's a perfect example. In this particular picture right here, we've developed what we call an intelligent digital prototype. Now we can change some parameters, just like you're used to in standard Inventor, by controlling some parameters like the height and the width and things like that. But it's also, you can see it's evaluating other things, and it's returning to me instantly the mass properties of this particular component, the shipping costs. It's evaluating and coming up with a part number. It's either looking through something or generating a part number for me. It looks like a revision number can be generated here. So it can do lots of things in evaluating all kinds of parameters, as you're seeing here in this form, in this dialog box. So you fill out this form, you hit go, and the model updates. Now when you talk about true conditional modeling, however, you might be able to extend it a little bit further and say, okay, all of the engineering's been done. I don't want anybody to make a decision on how wide it is or how tall it is, all that kind of stuff. But I want a decision based on a concept like seismic conditions. All right. So basic, in really basic language, if the load is a value and if seismic conditions are another value, then do something. Then the engineering is all going to take place. So it takes into account the parameters that you've entered in there for load and seismic conditions and does something else. Now, if you change that, then it knows what to do because the engineering is built into the model and it behaves accordingly. So you really don't have to make decisions that are part of your proprietary understanding or your tribal knowledge of these models. Those decisions can be built into your models, built into your assemblies. Okay. You can also take it and do a ton of other things with iLogic. You can perform all kinds of checks without reading all this kind of stuff. You can execute other macros and run other events. You can create drawings. You can read and write to spreadsheets, just all kinds of things. It's really outside of the limits of what the API does not allow us to do. If we can't get to the API, if that part's not exposed, it's really kind of iLogic can be used to do just about unlimited automation inside of Inventor to do all kinds of things. And I think Tim's got kind of an academic study on what he's going to show you today that kind of lets you not do just traditional design modeling, but kind of think outside the box a little bit and show you some kind of cool things, some ancillary things that iLogic is capable of doing. All right, so the perennial question. Are you ready to transform your business? I am going to hand things over to Mr. Tim now and let him share his screen. Whoop, Tim took the ball from me and he is ready to share his screen. So
take that.
There you go.
Okay, everyone should be able to see my Inventor screen.
Yep. That's good,
welcome
Tim.
Everybody to all of our attendees. I'm going to throw out, some of you may have heard me on these webcasts in the past. I used to do them on a regular basis with Carl, and have since kind of transitioned over into another group, as Carl mentioned, doing a lot of software development and particularly centered around data management in the product lifecycle management space and integration between systems. But am pinch hitting today one of our other senior applications engineers, Mr. Mayberry, was on deck to provide this part of the presentation. But as it turns out, Randy is, or I should say, the eye wall of hurricane flow is sitting about 10 miles off of Randy's back door. So Randy has no power and is wearing his high water pants, so we wish Randy all the best. So today is probably your prime opportunity to stump the chump. These are not my models. This is not my code. But I'm going to hopefully give you guys a good presentation anyway. So we open up with a simple, flexible gantry arm here. I might point out that the examples today, Carl mentioned talking outside of the box. I know you have all created, in your mind at least, truly amazing Inventor content, just innovative designs, and you just even impress yourself with how cool this new widget is. Well, of course, as humans, the first thing that we want to do is show it off. And as with many mechanisms, you know, often there is motion or could be motion involved, and it doesn't really show the best, doesn't really play well unless we can demonstrate that motion. So don't construe these examples as totally being a replacement for Inventor presentations, and you know that you can create new drawing content. Although in a limited scenario you could use that. You could use this process to that degree, but this is really intended as a show me tool. It's designed for, or you know, kind of developed around the concept, hey, I'm a designer, I want to show this to the engineering manager, or I'm an engineering manager or a project manager, I need to show this to the board of directors, or I'm a sales guy out in the field, I need to show this to my customer. You know, we need to demonstrate live motion. So, as I mentioned, we've got a simple gantry arm here. I might point out this first example simply has a few parameters in here, user parameters, that we're going to use to control the model. We've got things such as, you know, start position, end position, the value of the step. You'll notice everything is in a metric format. That was primarily done just for simplicity's sake. Those of you that have done iLogic development understand that the base units inside of iLogic are in centimeters, so that Randy didn't have to go through a conversion process to convert all of his values back and forth. He simply kept everything in a metric format. So first off, we're going to just drive the extend feature. So when I click that, you can see we're just running all three of those cylinders. They happen to be three instances of the same cylinder. So we're just running those cylinders through their extents from one direction to another. Likewise, we can rotate the entire model. So in the background, in the code behind this, so to speak, we're running an external iLogic rule and simply running through a loop, incrementing the value of those parameters by that step value. So we're going to rotate 10 degrees at a time through 150 degrees and then back again. Make sense? We can also combine both of those, so we rotate 150 degrees, then we extend out and we come back. Simple back and forth, roundabout motion. In the next example, we've got the front half of a articulated loader. So we've got multiple cylinders here. We've got two different cylinder types. We've got lots of hinge points, so we got a couple of linkages inside there. If we drive that example, we can tilt the bucket, roll it back, lay it back down flat. We can lift the arms up and down. If I would, and then let's do both. So we lift it up, roll the bucket, set it back down. Looks like twice. Make sense? So we're just driving those parameters through a range. Very much like how some of you may have driven constraints before. You know how you can right-click on the constraint, tell it to drive that constraint, and it just actuates on one constraint. Well, here we can, since we've got programmatic access to those parameters, we can loop through, sometimes at the same time, through multiple parameters. This Vise example is really kind of a unique deal. Randy assured me that this is one of those things that you could not do in a presentation, and that is make the use or to employ a rotational and translational parameter or constraint. So there's a rotation constraint on the drive shaft for this vise. So if we run it through its options, you can see there that it cranks open, cranks shut, drops the block of wood in there, tightens it up, loosens it back off, and removes the block of wood. So here we get motion, we get rotation, we're rotating the model as we go. So we're driving, again, we're driving multiple constraints all within the same package. Now the pencil example has a lot more things that we can do to it. For instance, we can explode. Here we're just driving the parameters for the offsets. So we explode that mechanical pencil tip, show all of its parts, and we can reset it, put it back together. So one of the things that we've been doing throughout all these examples is controlling how we're viewing the object. And this camera example really makes gives a good explanation for that. So to start with, we've got a standard cube here. Randy's built a model that has, you know, all of the faces named appropriately so that they correspond with their view. So top view is top, front view is front, and so forth. First thing we're going to do is cycle through all of the available views, available meaning available in the API, and we'll actually display here in the upper left-hand corner. We throw a screen graphic up there showing you what the current view enumeration is. So there's K left view orientation, K back view orientation, and so forth. So at any point in your iLogic automation, if you need to set that model to a specific view or viewpoint, however you want to look at that, you can drive that view and simply pass in that enumeration value, and it sets the model to that view. I think it's probably important, we've got one down here at the bottom too. You wanted me to make sure that I showed this. Here we're just rotating that model as if it were on a turntable, just spinning it around. And you can see we've got parameters here for camera height and camera eye distance. Well, what happens if we would change that? Let's say change that to 5 and rotate the camera. We can see we just moved the camera up. Now we've got a higher view of a higher degree of view. We're standing on a step ladder. If we bring it down to 1, now we're going to be down to almost street level. Can barely see the top. So I think you understand how that works. Excuse me, I had to pause myself to sneeze. So let's see really what we're meaning by this camera height and the camera eye distance. So here we've got just a simple sketch line. We've got 2 points. If I'd rotate things around here so you can see a little bit better. Every camera object has an eye. Think of that as your eye looking through the viewfinder on that camera, and it has a target. It also has an up vector parameter or property telling it which way is up. We don't have the up vector displayed on here. So right now the target is at 0, 0, 0. It's at the origin of this part. If I were to add a little bit to the Z value, you'll see this center point hop out here towards the front a little bit. So you can see that move. If we would raise the camera just a little bit, we'll see that move up as well. So now if I move the camera to look straight down that line, now I'm viewing from a higher point than I was before. I'm not looking as far back into the model. So it changes my perspective. So think about this. We could apply that to a particular view that we were trying to develop. We once did a project here several years back where the client wanted to be able to display not only the standard views that Inventor provides, but they wanted a diametric view of the drawing, or of the model. So their end view, they wanted to end up with something that looked roughly like that. Okay. We also have the ability, if you're going to create some kind of a reports and you've got, the view exactly shown the way that you want it, we can capture an image that just takes a screenshot of your current workspace. It discounts all of the panels over to the left, toolbars and everything. You just get your working space. We take a peek at what that image, so there's our view. So now we could save that, copy it, embed that in some sort of a presentation document, call it whatever you will. Gives you more infinite control than simply, manually rotating things around and trying to do a screen grab of it. Okay, if we go back to the pencil example, we've got some other parameters that we can drive here. You'll notice how this is kind of a knurled grip. Well, we can change the style of the grip, and we can make this silver instead of yellow. We could change the text. We'll say iLogic rocks. And let's see, so there we can see the new text on there. And we also have control over being able to view over specific model objects. I need to explode this first, so we'll run through the explode again. And then let's say I want to zoom into the clip. So boom, there's the clip. I want to look at the spring. Zoom, there's the spring. There's the dispenser. There's the cone. We can even drive that camera view along a 3D path. We actually used a 3D sketch to define that path, so this almost gives us that flyby or walkthrough effect. So we could define that. Think of, if you really are thinking outside the box here, you're already trying to decide, okay, how can I define a path that allows me to cruise by the object, change my camera angle at the end so that I swing around the backside and then cruise back up the other side. And that really brings us to the end of our presentation from my perspective, Carl.
Very good, Tim. Thank you very much. So you guys can see the point of this. You have to pass me back the presenter role there, Tim. Thank you, sir. The point of all of this was fairly academic, but it was more to just show some. We can just do more than just change the height and the width of these components. So if this is something where you have a need to be able to drive a a presentation, or maybe even do this with all the high-end rendering stuff on Inventor. So you've got the ambient shadows and the textures and all that kind of stuff. So it takes a little longer to kind of finish out the screen, and the reason we didn't turn it on for this presentation. But it's all about saving the mouse clicks, no matter what aspect of Inventor you're using. By kind of consolidating things and making things your own, it certainly saves a ton of mouse clicks throughout the day and throughout the week and throughout the month. And of course, we all know that all equates to a higher productivity schedule. So where do we go from here? I just wanted to point out that part of our services involve a discovery session. So if you've got things that you want to talk about, I am anxious to talk to you about them. So myself and my team get to visit folks, like I said, all over the country to talk about their needs, what they need to do, what they want to accomplish, and then we help them figure out how they're going to accomplish that by optimizing it through through whether we're writing code or doing training or anything like that, and then continuing support from there, whether we're increasing your productivity through more training or additional training, over the shoulder, live online, all these kind of things that we do to support, as well as our standard support contracts. So you're constantly able to have a contract, call, and get the answers that you need. Our services also involve, by the way, while I'm chatting about these last slides, if you guys want to enter some questions on the attendee list over there, you can type them in there, and then we'll catch to them right after we're finished here. Our services that we offer are related to consulting, of course data management. That's a great big slice of what we do nowadays, as well as implementation and integration services, simulation services, and then automation. It's not really in here, or well, it is process automation. You can call it that. Process automation and software development would be where the bucket that iLogic falls into. Our training is both live online and in person. We offer custom classes. We offer blended learning, where you kind of do a set of work on your own offline, and then meet with an instructor at the end of the week. Those types of things. Lots of ways to get the knowledge transfer that you're looking for. So that would be what wraps up our presentation. I'd like to spend the next few minutes talking or answering questions if we have any. Janet, do you see anything there?
One moment while I end today's recording.
All right.